Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now going to be going through question number 9 from the practice paper for the Cambridge IGCSE 2025 new syllabus. This is from the 0580. We have a non-calculator paper now, and this is one of the questions from the paper 2, the non-calculator paper, or the practice paper they put out to help you get ready for the new syllabus. So here we got a question about transformations. It says, describe fully the single transformation that maps triangle T onto triangle U. Okay, and I mean single transformation because sometimes you can, make a transformation with a series of steps, but here we want the single transformation. Now, whenever you see a transformation where the object and the image are different sizes, then for sure in our syllabus it's going to be something to do with enlargement. Okay, we deal in our syllabus only with translations, with reflections, with rotations, and with enlargements. So translations and reflections and rotations, the object and the image will be congruent, exactly the same shape and the same size. But with enlargements, the object and the image will be different sizes. They'll be the same shape, but different sizes. They'll be similar shapes. So whenever you see this kind of situation, even if you're not sure exactly how it works, if you see one object bigger than the other, then for sure it is an enlargement, something to do with enlargements. So we've got to map triangle, we've got to find the transformation that maps T onto U. T onto U, so the object has got smaller. And we can see here that it's kind of like inverted, kind of like upside down as well, right? So it's definitely an enlargement. And how do we deal with such an enlargement? In general enlargements, it's very, very simple to deal with them. You just take a point and you join it to its corresponding point using a straight line. And you do that for all the points if you want, but you just need 2 at minimum. So for example, we could join together the right angle point, which the corner with the right angle with the corner with the right angle. And we could join together the point which has the small angle, the smaller of the 2 angles, this one over here, with the corresponding point. Okay, if we join them together, we can see very clearly where they intersect is going to be the center of enlargement. So this slip down a bit. If you want to, you can do the same for the third corresponding points, the corners, and you can see very clearly that these corners, they all intersect. If we did this with some accuracy, they all intersect at the same point, which is this point over here. Okay, so this is an enlargement, and we have pinpointed the center of enlargement. So this is 3 and this is 4. So we can mention a couple of things about this enlargement. We can mention that it's an enlargement. So that's the first thing they want to see. You give the type of transformation. The second thing they want to know is the center of the enlargement, which we've just pinpointed, which is 3, 4. And finally, they want to know the scale factor of enlargement. The scale factor of enlargement. I'll put that over here. Scale factor. Now, how do we determine the scale factor of enlargement? Well, basically, we look at an object or a length on the object and compare it to the corresponding length on the image. And it's always the image length divided by the object length. It's always that way around. Okay, so we're going to start with the length on U. So for example, if I take the length from the right angle, the shorter length, okay, from here, this is 1 to 2, this is 1 unit to the right. Okay, so you have 1 unit to the right divided by, now if I take the same length from the object, the original shape, and start from the right angle, I have to go the opposite way to get to the same point. Here I have to go from the right angle to the right, here I have to go to the left, and I have to go 2 squares, so that's going to be -2. So we can see the scale factor here is -1/2. The scale factor is -1/2. So whenever you have the image smaller than the object, the scale factor would be its value less than 1. And whenever you have the object inverted, kind of like upside down compared to the image, then you will have a negative scale factor. Okay, so here we have a negative scale factor. The object has got smaller, became the image is smaller than the object, so it's a number less than 1, and also it's like twisted around, it's like inverted, so therefore the scale factor is negative. And you can see how mathematically that works. For example, I could have said on the image, to go from the right angle, you've got to go up 2 spaces to the longest, along the longest length, the longest one of the two, these two, okay, the two shorter sides. And so that's +2. And then here, to go from the right angle to the same point, you're going to go down 4 spaces. So it's going to be 2 divided by -4, which gives you again -1/2. So whichever way you do it, you end up with the same answer. Okay, so that's very important for us to understand how to deal with these type of enlargements. That's question number 9 for us from this paper. Other questions from this particular paper can be found in the playlist on the top right of the screen at the end of the video. Other questions from the topic of transformations from this new syllabus you can find in the playlist at the bottom right of the screen. You can find other questions dealing with transformations from the old syllabus in this playlist, and you can subscribe to my channel by clicking on this link. Thank you for watching, and see you soon.